So here we're talking about how do electron configurations relate to the periodic table. And for this section, you want to know, you want to remember that there's the S, P, D, and F blocks. And in this section, you also want to remember our 5 exceptions from electron configurations, which are chromium, molybdenum, copper, silver, and gold. So you definitely want to make sure you remember that. You also want to remember that when elements are doing things, they are striving for that stable octet, and for whatever energetic reasons, when you have 8 electrons in your valence shell, it makes you pretty stable. So when you're an element, you're going to gain electrons or lose electrons to become like that. So we have 2 examples down here. What these are called isoelectronic. And when you are isoelectronic, it means that you have the same electron configuration, and it also means that you have the same number of electrons. So if you look here, helium, totally normal, this is an electron configuration here, has 2 electrons. He's a noble gas, he's stable. If you look up lithium on your periodic table, he's number 3, which means normally he has 3 electrons. But when you see lithium as an ion, he's typically +1. And remember, if you're positive, that means you've lost an electron. So when lithium is +1, that means he has 2 electrons. And what you're noticing here is that he is becoming electronically the same as helium. And that's why lithium typically is +1, because when he loses that 1 electron, it makes him like a noble gas, and that makes him more stable and basically more energetically favorable. So most metals lose electrons, and now we also have ones that gain. So if you look up neon, neon has 10 electrons. And again, here's his noble gas with 10 electrons. Fluorine typically has 9. He's number 9 on the periodic table. When fluorine forms an ion, fluorine will only form a -1. So when fluorine is -1, that gives him 10 electrons. And what you'll notice again is that makes him exactly the same as neon. So why is fluorine a -1? Because when he gains that 1 electron, that is all he needs to be the exact same as neon. Only other thing with this one is you should know you can be called what's called pseudo-isoelectronic, where you're exactly the same except for d electrons. So if you look here, we have argon as an example and manganese +2 as an example, and you can see they look exactly the same. It's just that there's some d electrons hanging on. D electrons are those inner shell electrons that elements really can't gain or lose typically. So basically for manganese, this is as close as he can get to being a noble gas. So he typically is +2. I mean, that's usually his charge, but the reason why he just can't be exactly like a noble gas for him. And then the last one, just remember, when you are an ion, you are working to gain or lose them so that you are a pseudo-isoelectronic or isoelectronic with noble gases. And again, that's why you're going to lose or gain electrons. And remember, you lose them from the highest energy level first. And again, that principal quantum number.